Hello everyone! Do you know how to solve simultaneous equation using the matrix method? If your answer is no, then let me show you how. Now my first step is to write the matrix equation AX is equal to B. Alright, so after writing the equation, I will be writing a matrix for A, X, and B. Now, matrix A is made of the elements of the coefficients of my system of equations. So, the coefficient of 4x is 4. The coefficient of negative 5y is negative 5y. The coefficient of 3x, is 3. The coefficient of 2y is 2. Alright, so that is matrix A. Alright, matrix X is made up of elements, just the variables x and y. And matrix B is basically made up of the results negative 6 and 7. Alright, so at this point, remember I need to solve my simultaneous equation. So therefore, AX equal to B, solving for x would mean that I will have to ensure that x is on the left-hand side of the equation, and I will take the other terms to the right-hand side of the equation. But if you notice, a is being multiplied by x. So therefore, I will multiply the left-hand side by x, and I will divide, the left-hand side by x, and I will divide the right-hand side by a, not x, a, Alright, so if you notice, there is a common factor in the numerator and the denominator. So I can say I can get one set of a and one set of a out of the denominator. So at this point, I'm left with x is equal to b over a. Alright, please note that this can also be written as x is equal to 1 over a times b. Okay, note that 1 over a is also called a inverse. Thus, I can write my equation as x is equal to a inverse times b. Alright, now at this stage, I need to find what a inverse is. Now, if you checked a previous video, you would realize that a inverse is equal to simply 1 over the determinant of a times the adjoint of a. Or some persons might say a adjoint. Alright, so I now need to find the determinant of a and the adjoint of a. So I'll be doing these one at a time. So the determinant of a is simply to first write the elements of a, because we need to know what we're working with. So that's 4, negative 5, 3, and 2. Alright, so to find the determinant, I will first find the product of the elements of the leading diagonal, which are 4 and 2. And then I will subtract the product of the non-leading diagonal. Okay, so those are 3 and negative 5. Alrighty. The product of 4 and 2 is 8. The product of 3 and negative 5, is negative 15. So therefore, the determinant is equal to 23. Alright, so I can write that the determinant of A is 23. Alright, now I need to find the adjoint of A, or A adjoint if you so choose to. How do we find the adjoint of A? Alright, so A adjoint is equal to, alright, so looking at the matrix for A, we would first interchange the elements of the leading diagonal. Alright, so what we will do, the 2 will replace the 4, and the 4 will be positioned where 2 was. Alright, then we will multiply the elements of the non-leading diagonal by -1. So -1 times -5 is a +5, and -1 times 3 is a -3. Alright, so now that I've found the determinant and A adjoint, I can now substitute these results into the formula for finding the inverse of A. So that is 1 over the determinant, which we have found to be 23, times the adjoint of A, which is 2, 5, and -3, and 4. Alright, so now we have a situation where the determinant now acts as a scalar. Alright, so at this point, I will multiply 1 over 23 by each of the elements in this matrix. Alright, that is 1 over 23 times 2. Let me see how best I can squeeze it here. Times 2. Alright, 1 over 23 times the second element, which is 5. Alright, 1 over 23 times -3. And finally, 1 over 23 times 4. Alright, okay, so just adjust this. Alright, so I can tidy this situation right here, or this matrix right here, sorry, to have A inverse is equal to, alright, so 1 over 23 times 2 would be 2 over 23. Alright, so 1 over 23 times 5 would yield 5 over 23. 1 over 23 times -3 is -3 over 23. Alright, and finally 1 over 23 times 4 will yield 4 over 23. Alright, so there you have it. We have A inverse, but we're not quite finished as yet. Alright, remember our matrix equation is X is equal to A inverse times B. Alright, so just rewriting that portion of the equation, A inverse times B. At this point, I will list the elements of A inverse, which I found to be 2 over 23, 5 over 23, -3 over 23, 4 over 23. Alright, so X is equal to A inverse times matrix B, and remember that matrix B is -6 and 7. So at this point, we'll be applying matrix multiplication. Alright, so at this point, I will use the elements of the first row, and I will multiply those elements by this column. Alright, so it simply means that I would multiply 2 over 23 times -6. Alright, so its first element with first element, right? Now I'll be multiplying the second element by 7. All right, so plus 5 over 23 times 7. All right, now at this point I will use the second row, the elements of the second row, and I will also multiply by elements negative 6 and 7. All right, so it's negative 3 over 23 times negative 6 and 4 over 23 times 7. All right, so let me just put that in writing. All right, plus, times negative 6 plus 4 over 23 times 7. All right, so apologize for the writing right here. I left some space right there. All right, so just tidying this up a bit. 2 over 23 times negative 6 will yield negative 12 over 23. All right, plus 5 sevens 35, so that's 35 over 23. All right, and in the denominator, negative 3 over 23 times negative 6 will give me 3 6s 18 over 23 plus 4 sevens 28, so that is 28 over 23. All right, and this is equal to x. All right, so continuing, just tidying up a bit. All right, so negative 12 and 35 will give me 23. Right, the denominators are the same, so that's 23 over 23. All right, and then now 18 plus 28 will give me 46. The denominators are the same, so that's 46 over 23. All right, so simplifying 23 over 23, I would have 1. All right, 23 divided, well, 46, sorry, divided by 23 is 2. All right, so therefore our solutions are 1 and 2. So there you have it, solving simultaneous equation using the matrix method. All right, so if you have any questions or concerns, feel free to comment down below. All right, and if there's any other topic that you would like me to assist you with revising, I am at your service. Goodbye.